All right. Hope you all are doing well. Today we're going to be working on a memory diagram that works a lot with lists, accessing values in lists, adding values in lists, and manipulating lists using while loops. So let's get started. Just as always, I want to reiterate the whole reason we are doing memory diagrams is so that we can learn how to read like a computer. And computers read top, bottom, read left to right, analyzing one line at a time. And then they also work inside to out. And when I mean inside to out, like let's take line 23, for example, we're appending a value to list one, but until we know what to pass into here, we cannot actually append something to it. So we have to evaluate this function call first and then pass it into this append function. Cool. So let's get started. So we start on the top. First line is human for humans only, for human eyes only. So we ignore it and move on. Second line is empty. Third line is where we're actually doing something. So we have a function definition. We have no call to it, so we have no reason to actually step into this function. So instead, we're going to store it in our globals, or store a reference to it in our globals and store it over in the heap so we can reference it later. So the name of this function is change and check. Change and check. We're going to give it an ID of 0, first available ID, and then over in the heap, we're going to store ID 0 as a function from lines, let's see, starting from the function signature to the last indented line of code, we have 3 through 16. 3 through 16. Little happy little box around it, and we are good to go, ready to move on. Cool. So next we move on to line 19. Line 19 again is another function call. It has some significance in that it is what we call the main function, but it's just another function like any other function. So until we have a reason to use it, we're just going to store it for later. So again, in globals, we're going to create another reference to this function, and then over the heap, we're going to store it. Lines 19 through 24. Great. And let's move on. 25 is blank. 26. 26, we finally have a function call. In particular, it's calling main. So we create new frame. I'm going to call it the main frame. We're going to create a return address and return value slot. Return value don't know right now, though, spoiler alert, the return value is none. So we know that there will be a none there. So if you want, you can just go ahead and add that in. There's nothing wrong with leaving it until the end. Return address is going to be a line where the function was called on, so line 26. Right. And now, as always with any function, we check to see if we need to put any parameters in here. So let's look here. No parameters, so we are good to step in. The doc string for humans, ignore that. Line 21 is our first local variable. Its name is num1. Oh my goodness. Underscore 1. And it has a value of 0. Just real quick. Name of the function, it's of type integer, and we're setting its value to 0. Great. Next, line 22. Line 22 creates another local variable. We're going to call that one list1. Its type is a list of integers. And then we've assigned it the values 1 at index 0, 2 at index 1, and the value stored at num1 at index 2. Let's walk through this slowly. First, create a little slot to store our value. And before we can actually put something in here, we have to go over to our heap and actually create it. So over in our heap, we're going to create a new list object. We give it the next available ID, which is ID2. Declare its type, which is a list of integers. And then we're going to look and see what we need to fill it with. So the first item, index 0 is 1. Second item, index 1 is 2. So let's get started with that. So index 0 is going to be 1. Index 2, or excuse me, index 1 is going to be the value 2. And what about index 2, our third item? Well, when we created this, right, we were inside of our mainframe. Num1 is defined in our mainframe. Notice it's indented just like list1 is. Num1 is defined in our mainframe as storing the value 0. So when this list1 is created, the value of num1 was currently 0. So that is what we store for index 2. Before we finish up, we need some way to access this list when we're working over in our stack. We take this ID 2 and we store it in list1 in our local variable list1. Oh, we're ready to roll. Line 23 says, okay, take list1 and append or add to it whatever's inside these parentheses. Well, what's inside these parentheses? Well, we have a function call with some arguments. We know it's a function call for a couple reasons. First reason, the most obvious, we have these parentheses here. Just like this is a function call, append, this is a function call, change and check. So I know I have a function call. Next, I also know I have a function call because stored this in globals. I'm aware that change and check is a function defined from lines 3 through 16. So great. Whenever I have a function call, create new frame. I'm going to name this one change and check. And as always, create a return address, return value. Return address is going to be the line it was called on, so line 23. And the return value we don't know yet. We do know it's going to be some sort of integer because we've explicitly said, hey, the return value is going to be an integer. But we don't know what it is yet. What's next? Well, we need to fill out our parameters. We have two parameters here. We have a integer parameter that's referred to as x, and we have a list of integers parameter which is referred to as nums. These are positional arguments. We didn't we didn't declare which one is x and which one is nums, but so we go by position. So the first argument lines up with the first parameter, and the second argument lines up with the second parameter. So we go and put in our parameter names, so x and num. And then we store our arguments inside of them. So 2 is going to go into x. And the value stored at list 1 is going to go into nums. 2 is easy, just a number, just an integer. Now list 1 kind of goes into our idea of scope. So when we're building out this function, nums refers to this list of integers, right? But we defined what nums is going to be inside of the main frame. Notice, to build out this function, we had to look inside of our main frame, what was indented inside the main function, which is where we're working on in in this frame right here. So list 1 refers to ID2 within the main frame. So when we pass it in to be nums, we also pass list 2 in to be nums there. ID. Great. All right, we have built out our parameters. We've created a return address. We've created a slot. We're ready to put in a return value. And now we're ready to step into this function. First line, it's just human readable code or human eyes only, so we're going to ignore that. And we hit an if statement. This statement, it's like any Boolean statement or conditional, says, hey, whatever this is, whatever follows this if statement needs to evaluate to true in order to step into this if block. So let's see. If x is less than 0, well, x is 2. So x is not less than 0, so we can't actually step into this block and return 0. We skip it and move down to line 7. Line 7 creates a new local variable. Name is I, its type is an integer, and the value stored at it is 0. So we'll say I, store the value 0. Next, we have a while loop. So while loops work like this. It's still Boolean conditionals. This value has to evaluate to true. So long as it does, we execute everything indented underneath. Once we've hit the last line that's indented underneath, we loop back up and then check to see if this value still evaluates true. If it does, we move in, execute the next 2 lines, or everything that's indented underneath. If it doesn't, we move on to the next undented line. So let's do this. Let's see. Well, I, which is 0, and we're checking to see if it's less than the length of nums. Well, nums refers to this dictionary this list right here. So the length of this list is 3. So what we're really asking is 0 less than 3. What is, so we can actually step in. The first thing we're doing inside, we're saying, okay, nums at I plus equals x. Well, what does that mean? Well, that's subscription notation. What we're really saying is, hey, go to nums, access index I. Go to nums, access index I, do something with the value stored there. In particular, add to it the value of x. Go to nums, accessing index I, which is 0. So we're really accessing the index 0 within this list. We are adding to it, so 1. So we're adding to it the value stored at x, which is 2. We get 3. Hope that makes sense. We're going to do it a lot, so doesn't. Hopefully some repetition will help. Next line, I plus equals 1, so all we're doing there is going to I, adding 1 to it. Right, we've hit the end of our indented block, so we will loop back up. Check now to see if I is still less than the length of nums. Well, I is 1 now. The length of nums is still 3, so is 1 less than 3? You betcha. So we step in and do the exact same task again, now with a different I. So nums at I, well, I is 1 now, so we're looking at this value here. We're adding to it a value stored at x. X is still 2, so we're saying take 2, add 2 to it. Great. We move down to line 10, add 1 to I, and then we loop back up. Now we're saying is I less than the length of num, so is 2 less than 3? You betcha. So we are good to step in. Line 9, the nums I and nums at 2, accessing this value here, we're adding to it x, which is 2. 0 becomes 2. We're reassigning the value of 2. We're reassigning to 0 itself plus 2. Great. And then we move on. Line 10 adds 1 to I, so I becomes 3. And then we loop back up. Now we're checking if I, 3, is less than the length of nums, which is 3. Is this true? No. We are done with this while loop. We can skip lines 9 and 10, and we move on to lines 11. Now, line 11 reassigns the value stored at I to be 0. So we had been upping it over and over. Now we're changing it to 0. And we're entering another loop. Save some time. I'm gonna stop doing these little fun things over here. Just kind of assuming we know that we're looping through this list and checking the length of nums. But if you're confused, just rewind the video and look at what we did for this while loop. So we're asking ourselves if I is less than the length of nums. Well, 0 is less than 3. So now we're performing a check saying if nums at I is equivalent to 2. Well, nums at I, this is this. This is not equivalent to 2. This is not equivalent to 2. So we don't enter this if statement. And instead, we up I by 1. Great. Let's loop back up. Now I is 1, and we're checking to see if 1 is less than the length of num. So is 1 less than 3? Sure is, so we can step in. If nums at 1 is equal to 2 is essentially what we're saying. Nums at I, we're asking if it's equal or equivalent to 2. Well, nums at 1 takes us to 4. 4 is not equivalent to 2. So we ignore everything indented underneath and we up I by 1. So I becomes 2. Finally, we'll loop back up. 2 is less than the length of nums, which is 3. So we perform our check one final time. If nums at I is equivalent to x, nums at I, that takes us here, is equivalent x. Well, 2 is equal to, so we are allowed to step into this if statement. This if statement has a return state, or this if block, excuse me. This if block has a return statement. Now, return statement is one of the few ways you can actually break out of a loop. Notice we had to go all the way up to 3 in this loop in order to break out of it, right? But we've hit this return statement. Return statement, as soon as you legally hit it, and we legally hit it because this was equivalent to this, 2 is equivalent to 2. So we've legally hit this return statement. And as soon as we get a return statement, we evaluate what follows it, which is 0, and we put that in our return value slot. Now, as soon as we have something in a return value slot, we immediately take it back to where we found it on line 23. On line 23, we replace this whole thing right here, the function call, with its return value, which is 0. What this ends up being is list 1 append 0. Append just adds a new value to our list. So our list now has index 3. We're assigning it the value of 0. And with one function call, I'm going to make a little bit more room here. And let's move on to line 24. We were on 23. We're done. We did everything we needed to do here. We move on to line 24. Line 24 does the exact same thing that we did with line 23, except that now our arguments are 3 and list, which has changed significantly. So we can't predict the exact same values inside of our new change in check as we would in our last change in check, because we're dealing with very different variables. So let's go ahead and start our change in check function frame. Change and check. I give it a return address slot, return value slot. Return address is the line it was called on, line 24. 24 there. Then we gotta fill in our parameters, x and nums. X, nums. Well, positionally, excuse me, 3 lines up with the first parameter here. So x is going to be 3. And list 1 lines up with our second parameter of nums. So the value stored at list 1, remember, oh, excuse me, yeah, remember we're back in our main frame. List 1 is ID 2. So the value stored there is assigned to the value nums. So ID 2. Great. Create our return address slot and return value slot. Created our parameters. We're ready to step in. So we're asking, is x if x is less than 0? So we're asking ourselves, hey, is x less than 0? If it is, step in and return 0. Well, x is not less than 0, so darn, we don't have that quick way out. So we have to move on and create our little I variable, our index counter. I is going to be assigned the value of 0. Alrighty. Setting up our while loop again. I is 0. Looking to see if it's less than the length of nums. Oh, well, we did add a value, so now the length of nums is going to be 4. So I is still less than the length of, or 0 is still less than 4. So we're going to take nums at I, add to it the value stored at x. Nums I takes us to this 3 value. We're adding to it value stored at x, 3, becomes 6. Great. And I add 1 to I becomes 1, and we loop back up. 1 is still less than 3, so we're going to go to nums again, access index 1, add to it the value stored at x. So the value stored at 1 is now 7. Make that a little easier to read. All right, cool. And then finally, we're going to add 1 to I. It becomes 2. And we loop back up. 2 is still less than the length of nums. 2 is still less than 4. So nums at I plus equals x. Nums takes us here. At I takes us here. Accessing this value, we're saying, okay, add to this value the value stored at x, which is 3. So our new value is 5. Done with line 9. Head to line 10, add 1. I plus equals 1 gives us 3. And we will loop back up. 3 is less than the length of nums, which is still 4. So we go to nums I, which is 3. Takes us here, accessing 0 value. We're adding to it a value stored at x, which is 3. Our new value there is going to be 3. Great. Finally, add 1 to I becomes 4. We check our while statement again. 4 is not less than the length of nums. 4 is not less than 4. So we get to skip. We skip down to line 11. We change I to be 0 again. Great. We're pretty close to done, y'all. Almost there. Line 12 is this that other for loop again. So it's just doing the exact same thing, checking to see if 0 is less than the length of our list, which is 4. It is indeed, so we check to see if nums at 0 is equivalent to x. Nums at I is equivalent to x. So nums at 0, 0. So this value here, we're asking if this is equivalent to x, which is 3. Is it equivalent? No way. We don't step into our if statement. Instead, we add 1 to I. All right. Looping back up. 1 is still less than the length of our list, which is 4. We check to see if the number stored in nums index 1 is equivalent to x, which is 3. Well, the number stored at index 1 is 7, not equivalent to 3. So we skip that return statement, add 1. Add 1 to make 2. Cool. Looping back up, checking again. Is 2 less than the length of nums, which is 4? You betcha. So we test to see if nums at 2 is equivalent to x, which is 3. Well, nums at 2 is 5. Is this equivalent to 3? Away. So we don't return 0. We are forced to move on. So we add 1 to I becomes 3. And we loop back up. 3 is not, or is less than 4. We're good to go. Move right in to line 13. If num's at I, so if num's at 3, the equivalent to x. Well, num's makes this here. I is 3, so we're accessing this value because we're accessing this index. We're saying is 3 equivalent to x? Is 3 equivalent to the value stored at x? Yes, hooray! So we step in, we return 0. So hit a return statement, take that value, follows the return keyword, plug it into our return value slot, and immediately take that value back to line 24. Line 24, what were we doing? Well, we were appending something to list 1. What were we appending? Well, whatever we get when we finish our change in check function. Change in check function, this whole thing is replaced with this return value. This whole thing essentially is list1.append 0. We create another value and assign it to the next available index, which is 4. Okay, are we done? Well, let's see. We've hit the last line of our main frame. We never hit a return statement, which is good because we specified none in our main frame. We return none to line 26. Well, what were we doing on line 26? Well, all we were doing was calling main. So we're done with that, and we are done with our code snippet. Great. I hope this helped y'all. As always, if any of this is confusing or you want to practice over it, please come to office hours or tutoring. Lots of TAs that are ready and anxious to help you understand this. Great. All right. Well, have a good one.